Hi guys, welcome back to another video. Today we're going to be looking at the following combinatorics problem from Mathcounts 2021. And let's get a quick read before we start. In the dice game 0, a player rolls 6 standard 6-sided dice and then scores points for certain combinations as shown in the table. A die cannot be used in more than one combination. So if we zoom in on this table, we'll see that different patterns, different arrangements have different point values. So let's see. It says, for example, a person who rolls a 1, 5, 6, 4, 4, 6 scores 50 points. And we can see how. Because if you look at the table, scoring a number 1 and then rolling the number 1 and rolling the number 5 each give 25 points. And because we did both, we get 50. And you see we have 2 6s and 2 4s. Neither of those give us any points, so that we get a total of 50. Now if you look at 1, 4, 4, 4, 1, 4, this would be 250 points because we rolled 2 1s, so 2 times 25, that's 50. And then we have 4 4s, so 4 of a kind is 200, so that's a total of 250 points. Okay, so now that we understand how the point values are associated, we read the question, which says that what is the probability that the player scores 0 points? Okay, so with this, we basically want to look at a roll, right? We want to look at a roll of 6 numbers such that 0 points are given. So right off the bat, if we look at the last two rows, we know that the numbers 1 and 5 automatically give points. So that means the only digits that we can use to fill up our 6 die rolls are 2, 3, 4, and 6, right? And it can be in any order. I could have 2, 2, 3, 3, 4, 6. I could have, obviously we're going to repeat some digits, right? Because there's 6 spots and only 4 digits. Now we look at the rest of these. So let's just get a quick read first. So, okay, so these 3, 4, 5, and 6 of a kind. So this right here automatically tells us that we cannot have more than 2 of the same number, right? If I have 2 twos, then that's fine. But I can't have 3 twos because then I get 100 points at least, right? So automatically we know that I can only have the highest I can have for one single number is 2 of them. Now I also know that I can't have 3 pairs, right? So I can't have, because I can make pairs, but they're saying you can't make 3 pairs. So I could have a max of 2 pairs. Okay. And then the last one that we haven't looked at is right here, 6 distinct numbers. We don't have to worry about this because we've already eliminated 1 and 5 from our potential rolls. So that's automatically taken care of. So basically, I need to have a max of 2 pairs, right? So it could look something like this: AA, BB, C, D, where A is equal to one of the digits, B is equal to another one of the digits, and then C and D are the other 2 digits, right? So that works because we have a max of 2 pairs, AA and BB. I don't have 3 of a kind or higher, and I'm not using 1s or 5s. Now let's think, okay, we know we can't do 3 of a kind. What if I do only 1 pair? So I do AA, B, C, D, right? This is problematic though because we need a 6th roll. And now whatever the 6th roll is, if it's an A, I get a 3 of a kind. And if it's B, C, or D, then that we are accounted for. That's just this situation, right? So ultimately, you'll see that this is the only form that gives us 0 points, right? Where A, B, C, and D, so if we write this out, A, B, C, and D are just some combination of 2, 3, 4, and 6. And that's pretty much what the problem is reduced to now. So let's start. Whether A is 2 and B is 3, or A is 3 and B is 2, that doesn't really make a difference, right? We want to make sure we don't overcount or anything. So let's see, how many ways are there to assign the digits to A, B, C, and D? Right, so we have 2 of our digits are going to be used twice, and 2 of them are only going to be used once. So there's 4 choose 2. This is the number of ways I can pick the two digits that use twice. So the number of ways to pick two digits A and B, right? Because 4 choose 2, out of the 4 digits, 2, 3, 4, and 6, I want to pick 2 of them to be the pairs. And then that means that automatically, say I pick 3 and 6 to be my A and my B, then automatically my 2 and my 4 have to be the C and the D. So we have just 4 choose 2. We could do that out real quick. 4 times 3 over 2 is equal to 6. So that's the number of ways to pick my digits to correspond to some letters, A through D, right? Okay, so we have that now. Now, each of these 6 ways, we need to see how many ways are there to actually arrange the numbers, right? Because I can order them in any way. Sorry. I could do any ordering I want. I could do, for example, 1, 1, 2, 2, or sorry, not 1, 1, 2, 2, 3, 3, 4, 6. This is valid. And then 2, 3, 3, 4, 6, 2 is another valid. Right here, that's another valid arrangement. So we want to see, for each of these 6 ways, how many ways can I arrange my digits? Well, that's not too hard. There's 6 digits, so 6 factorial. And we divide this by 2 factorial for the 2 A's, 2 factorial for the 2 B's, and then 1 factorial for the C, 1 factorial for the D. So this is just 720 divided by 2 times 2, which is equal to 180. And this right here is called a multinomial coefficient. Multinomial coefficient. So if you want to look at this, you could definitely look that up and learn a little bit more about it. So that's 180. And now 180. So we have 180 times the 6. So 6 times 180 is your number of ways to arrange it, right? And then now we just have to figure out our denominator. That is 6 to the 6, right? There's 6 dice, 6 possible rolls. And now we simplify. This is the same as 180 over 6 to the 5th, 30 over 6 to the 4th, 5 over 6 cubed. And 5 over 6 cubed, let's just get a little more space, is 5 over 216. And that is our answer, right? We could go back, read the question. The question's asking for our answer as a common fraction. So we write 5 over 216 and move on. So that should be all for this question. If you have any questions how we solved it, please leave a comment. Otherwise, like and subscribe if you enjoyed the video, and we will be back again tomorrow with another problem. Thanks for watching.